500 meters beneath Antarctica, where no sunlight has ever reached, something is alive. Tiny creatures, drifting, in total darkness, cut off from the rest of the world for thousands of years, and the ice above them, nearly 5 kilometers thick. From the air, Antarctica looks empty, barren, frozen, dead. It's not. Beneath that surface are rivers flowing uphill, lakes the size of cities, active volcanoes, air that's over 1 million years old. All of it is locked inside the largest freshwater reserve on the planet. And right now, the most powerful nations on Earth are racing to control it. China is building new year-round stations down there. Russia is running seismic surveys in contested territory. The geopolitical clock is ticking. So what is actually under the ice, and why does it matter this much? Let's find out. The continent. First, zoom out. Antarctica is the 5th largest continent on Earth, bigger than the United States and Mexico combined. It holds 70% of the planet's fresh water, locked inside an ice sheet thick enough to bury the Alps. It's the coldest place on Earth. Temperatures hit negative 90 degrees Celsius, winds top 200 miles per hour. In winter, parts of the continent go months without seeing the sun. And yet, life exists here, on the surface, in the ocean, and deep, deep beneath the ice. So let's go down. The Ice Library, Antarctica, is a library, an ice library. Snow falls here every year. It compacts under its own weight, layer by layer, like tree rings, but frozen. As it compresses, air gets trapped between the grains, tiny bubbles, atmosphere sealed in time. Scientists drill down and pull up long cylinders of this frozen history. They're called ice cores. The deeper the core, the further back you go. One of the oldest continuous ice cores ever recovered was drilled from nearly 3 kilometers down. The air trapped inside is 1.2 million years old. Think about that. We can literally open a bubble and breathe air from before modern humans existed. The ice preserves carbon dioxide levels, methane, volcanic ash, temperature signals. It's a complete atmospheric archive, one that records when the Sahara was green, when mammoths roamed, when CO2 levels were half of what they are today. If this ice warms, that record is gone. Forever. What happens on the surface? But this is still just the top layer, and something strange happens up here too. Most of Antarctica is covered in bright, reflective snow, but in some places, powerful winds rip that snow away, exposing something unexpected: fields of blue ice. This ice started as ordinary snowfall. It compressed until all the air bubbles were forced out. With no fresh snow on top, light goes deeper. The ice absorbs reds and yellows. What's left glows blue. In some regions, that blue ice is hundreds of thousands of years old, sitting right there on the surface, waiting. And then there's Mount Erebus, the most southern active volcano on Earth. Hot gases escape from vents. On its slopes, where those gases meet ice, they carve warm caves into the mountain. Inside those caves, scientists have found mosses, algae, and DNA sequences that don't match anything we've ever seen before. Life, in one of the least likely places imaginable. But the strangest thing near the surface isn't alive at all. In 1979, Air New Zealand Flight 901 crashed into Mount Erebus. All 257 people on board were killed. The terrain was unstable. The ice never stopped moving. Full recovery was never possible. Snow and ice buried the wreckage fast. Parts of the aircraft, and possibly human remains, are still locked beneath the ice today. The cold preserves the past. It holds it perfectly still. The paradox: east versus west. We're about 1,000 feet down now, and this is where Antarctica stops behaving the way people expect. Most people think of Antarctica as one giant block of melting ice. It's not. It's doing two completely different things at once. West Antarctica, ice is thinning fast. Glaciers are accelerating toward the ocean. Ice shelves are cracking apart. Some of the fastest ice loss on Earth is happening right here. East Antarctica tells a different story. It's colder, thicker. In some regions, snowfall has actually added ice. But here's the thing. Satellite data shows that despite those gains in the east, Antarctica as a whole has been losing ice for decades. The continent isn't responding as one system. That's the paradox. And it's why understanding what's happening in this transition zone matters. If we can't figure out what's going on here, we can't predict what comes next. The hidden world beneath. We keep going down, past 1 kilometer now. The pressure is extreme, and between the ice and the bedrock below, water is moving. Beneath Antarctica, there are thousands of rivers and lakes. They form a connected drainage system. Some of these subglacial lakes hold volumes of water comparable to major reservoirs in the United States. When they drain, it happens fast. Billions of liters released in days. Water traveling hundreds of kilometers across the continent, completely underground, unseen. As it shifts below, the ice above responds. The surface lifts and settles by meters, like weight moving across a frozen shell. We've barely touched any of this world directly. If you added up every place humans have physically reached beneath the Antarctic ice, it would cover about the size of a basketball court. So instead of digging, we fly. Helicopters sweep low over the ice carrying massive electromagnetic sensors, huge loops suspended beneath them. These systems send signals down through ice and rock. They reveal what's frozen, what's liquid, what's moving. We are echolocating a hidden continent. Blood falls, and occasionally, this hidden system reaches the surface. Taylor Glacier has a deep red stain bleeding out of it, streaking the ice like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, nobody could explain it. Algae was the first guess, but algae needs sunlight. This water comes from deep inside the ice. Look closely, and you'll see it actually comes out clear. It's an ancient brine, more than twice as salty as the ocean. Cold enough that it stays liquid at -5 degrees Celsius. It's been sealed beneath roughly 400 meters of ice for millions of years. When it hits the surface, dissolved iron reacts with oxygen. It oxidizes on contact. That's what turns the ice red. Blood falls gives us a window into what these hidden rivers are carrying beneath Antarctica. Iron, organic carbon, nutrients. There are thousands of subglacial outflows like this across the continent. Most never reach the surface. But when that nutrient-rich meltwater does enter the ocean, it fuels phytoplankton. Phytoplankton support krill. Krill supports everything above them. Everything is connected. The system starts beneath the ice. It ends with the largest animals in the ocean. Blue whales and planet-wild blue whales. The largest animals to ever exist on Earth. In the 20th century, we almost wiped them out. Between 1904 and 1967, more than 360,000 whales were killed in Antarctic waters alone. Blue whale populations collapsed by 97%. They're recovering. But there's still a problem. We don't understand them well enough. Where they breed, how they migrate, what conditions they need to survive in a rapidly changing ocean. And researching animals this large, in a place this remote, takes resources most people never see. That's why I became a Planet Wild member. Planet Wild is a community that funds one concrete nature protection mission every month. Think of it as crowdfunding for nature, but not the abstract kind. You don't just hear about problems, you see the work being done. Every mission is documented and published on YouTube within weeks. I joined because it's one of the few places I've seen where you can actually follow conservation work from start to finish. One of the missions I supported focused on blue whale research. Planet Wild funded drone-based monitoring, letting scientists study blue whales without disturbing them. The data they collected was made openly available. That fits this story. The Antarctic ecosystem only works if we understand it well enough to protect it. If you want to support this kind of work, you can join Planet Wild too. You'll start having an impact right away. And as a thank you, I'm covering the first month for the first 100 people who sign up using the link below. Scan the QR code or click the link in the description. If you want to see Planet Wild in action, check out their latest mission video on their YouTube channel. Deeper. The subglacial lakes. Antarctica's ice feeds the ocean. The ocean feeds the whales. Now let's go back under the ice. You're more than 3.5 kilometers down. The pressure is crushing. The darkness is absolute. And beneath the ice lies one of the largest lakes on Earth, Lake Vostok, 240 kilometers long, 50 kilometers wide, completely sealed beneath the ice for millions of years. It has never seen sunlight. It's been isolated from Earth's atmosphere longer than humans have existed, a potential habitat for microbial life unlike anything we've ever studied. Lake Vostok isn't alone. There are nearly 700 subglacial lakes scattered across Antarctica. In the few that scientists have sampled, they've already found evidence of life. In Lake Whillans, microbes survive by pulling chemical energy directly out of rock. In Lake Mercer, researchers found microbial signatures preserved in the sediment. And remember those amphipods from the beginning? The ones swimming in total darkness, hundreds of kilometers from any sunlight? That makes Antarctica one of the closest natural analogs we have to icy worlds like Europa and Enceladus, moons in our own solar system with oceans sealed beneath frozen shells. If life can survive under kilometers of ice down, Here on Earth, it widens the range of conditions where life might exist elsewhere in the solar system. Antarctica isn't hiding aliens, but it's showing us what alien life might actually look like. Heat from below. The deeper you go, the more heat you find. You're nearing the bedrock now, and it's not the solid, frozen foundation most people imagine. Beneath West Antarctica are dozens of volcanoes, hidden under kilometers of ice. Some of them are active. They don't erupt upward. The weight of the ice above suppresses explosive blasts. Instead, heat builds below. It melts the ice from underneath. It carves chambers of water and steam. That heat destabilizes glaciers. It accelerates ice loss. Scientists have found ash layers trapped in ice cores, evidence of eruptions that happened while the ice was still forming. More recent seismic data suggests some of these volcanoes are active right now. This geothermal heat wasn't accounted for in early ice models. It helps explain why parts of West Antarctica are changing faster than anyone predicted. The ice isn't only warming from above, it's being heated from below. The buried continent. But the volcanoes are only part of the story. They sit on the surface of something much larger, a continent, buried beneath kilometers of ice. Scientists have used data from millions of measurements to digitally strip the ice away. The result is called BedMap 2. When the ice disappears, the surface you thought you knew vanishes with it. What's left is a vast, rugged landscape that's been hidden for millions of years. Mountain ranges comparable to the Alps, completely buried. The Gamburtsev Mountains stretch across the interior, their peaks rising thousands of meters, unseen for millennia. Denman Canyon cuts through the bedrock nearby. It's the deepest land canyon on Earth, plunging more than 3.5 kilometers below sea level. Ancient river valleys run between them, preserved exactly as they were tens of millions of years ago. And BedMap reveals something even more fundamental. Antarctica isn't one continent underneath, it's two completely different geological worlds. East Antarctica is ancient, thick, stable, part of one of the oldest pieces of continental crust on the planet. West Antarctica formed differently. Over tens of millions of years, tectonic forces stretched the crust apart. It thinned, it fractured, it sank, creating deep basins long before ice ever arrived. That thinning brought heat closer to the surface. That's why West Antarctica hosts dozens of volcanoes beneath the ice. When Antarctica drifted south and ice started piling up, those low, fractured regions filled first. Strip the ice away today, and much of West Antarctica sits below sea level. The continent breaks apart into islands and highlands. Fossilized pollen and root systems preserved in the rock tell us this was once a green, forested land, with rivers and temperate climates, back when Antarctica was part of Gondwana. And then there's the Wilkes Land Gravity Anomaly, a circular structure 300 kilometers wide, buried beneath East Antarctica. Its origin is still debated. It could be one of the largest impact scars on Earth, or something else entirely. Whatever it is, it's massive, and it's hidden. Isostatic rebound. For millions of years, the weight of the ice has pressed Antarctica downward, pushing the crust into the mantle below. But when ice is removed, the land doesn't just sit there. Over centuries to millennia, it slowly rises back up. Coastlines change, drainage shifts, stress reshapes deep within the crust. Geologists call this isostatic rebound. The bedrock beneath Antarctica remembers a world without ice. The surface you started on does not. And this, all of this, is what nations are positioning themselves to control. The race. Why it matters. So why does any of this matter? Why are nations racing to build stations, run surveys, and plant flags across Antarctica? Because beneath the ice lies value. Antarctica shares the same deep geology as South America, Africa, India, and Australia. Continents rich in coal, oil, metals, and rare elements. Geological surveys suggest vast resources buried beneath the Antarctic ice, potentially worth trillions. For now, all of it is protected by the Antarctic Treaty, signed in 1959. It designates Antarctica as a zone for peace and science. It bans military use, it suspends territorial claims. But in 2048, that protection can be reviewed. And that review could open the door to extraction. Some countries aren't waiting. Russia has carried out extensive seismic surveys. They've mapped potential oil and gas resources in Antarctic waters. China is rapidly expanding its Antarctic program, building new year-round stations, investing heavily in logistics, mapping, and polar research. Meanwhile, the United States Antarctic program is dealing with aging infrastructure, uncertain funding, and growing pressure to prioritize elsewhere. The balance is shifting. The system. the subglacial lakes, the hidden biosphere, the ancient rivers, the ecosystem powered by iron and nutrients flowing into the Southern Ocean. All of it exists in a fragile balance that took millions of years to create. Antarctica is not empty. It's not simple. It operates as a connected system, from bedrock to ice to ocean. Heat shapes the land. Ice controls the water. Water carries nutrients. Nutrients sustain life. Change one layer, and it ripples through all the others. Systems like this take millions of years to form. They can be disrupted in far less time. The Antarctic Treaty has been held for over 60 years. In 2048, its protections can be reviewed. Countries are already positioning themselves. Technology is turning places that were once unreachable into viable targets. Some environments function precisely because they have been left alone. Antarctica is one of them. 2048 is roughly 2 decades away. The race is already underway. If you want to be part of protecting systems like this, join the Planet Wild community, link on screen and in the description. Antarctica is not the only frontier under pressure. Find out what else is at stake in the next video.